Alright, these are quick videos. We're going to quickly review all concepts. First one is a horizontal projectile. Okay, the V initial, okay, in the Y direction for this, okay, does equal 0. Okay, so we're going to be traveling in the horizontal direction only. Our X, of course, is constant velocity. So to get our distance in our X direction, we're just going to S equals VT, like that. Okay, and of course we're going to bust out a Fab 5 for this. We're going to have a different V final for this one. We're going to need an acceleration. That of course will be negative 9.8. I'll just say minus G here. Okay, and our distance on the Y, I'll just label that as Y, is going to be, you know, whatever this distance is here. Okay. So Y equals, I'll say H for height. And of course time is our variable we want to find. So we're going to bust out a Fab 5 to find time. The best one to do is D equals V1t plus 1 of AT squared. So we'll find the time it takes for this to fall. And then we'll put that in here for time. And our displacement that it falls in the X direction is going to be velocity times time. Now when this thing hits the ground, of course, we are going to have a vector. Okay, remember we have to Pythagorize the X direction velocity and the Y direction velocity. So I'll call this one Vx. And this one's going to be Vy. So to get the value of our hypotenuse, I'll x squared this plus y squared for that. Okay, so, and that'll be equal to our resultant velocity vector. So I'm going to Vx squared plus Vy squared under a square root. And I'll take the inverse tangent to get this angle here. The inverse tangent of Vy over Vx. Now for our projectile motion for angular, okay, we have an initial velocity vector here. And we are going to need to break that into x and y velocity. Okay, to get our y velocity, I'll just label that y. I'm going to take v naught times sine theta. And I'll label this one x, the velocity in the x direction. That'll be v naught cosine theta. Remember at the top of the parabola here, we're going to have a vector pointing in this direction only, because velocity in the y direction will be 0. And this will just equal our velocity in the x direction. I'll just label that x, so it's v sub x. Now remember, the time it takes for us to get up to the top is going to be the same time it takes to come all the way back down, assuming a symmetrical parabola. Okay, and our max height, again, is when velocity in the y direction equals 0. You can actually use this equation here to get the time it takes to get there. Okay, and if you want to get max height, it's easy just to do, you know, v final squared equals v initial, and I'm going to square that, of course. But remember, this is going to be in the y direction. Okay, plus 2 times negative 9.8. And then d, and d will be your max height. So, you know, that's projectile motion. A quick review of that.